Mic check. Trigonometry, Chapter 3, Radian Measure in the Unit Circle, Section 4, Linear and Angular Speed, Video 1, Linear Speed versus Angular Speed. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous section, we learned about the unit circle and circular trig functions. The unit circle is simply the circle on the Cartesian plane with center 0, 0 and radius 1, and has equation x squared plus y squared equals 1. The circular trig functions were defined for an arc length s on the unit circle starting at 1, 0, where counterclockwise is associated with positive arc measure. For such an arc whose terminal point is x, y, the circular trig function definitions were the same as the previous x, y, r definitions with r equal to 1. In this section, we learn about the relationship between linear speed of a point on a disk, on the edge of a spinning disk, and the angular speed of the disk. In this video, we introduce the concept of linear speed versus angular speed. When an object travels a distance of d over a time period t, the linear speed of the object is given by v equals d over t. This is like rate equals distance over time. The choice of the letter v to represent speed is for the word velocity, although technically speed and velocity are different things. Speed is a rate of change, like 60 miles per hour, whereas velocity is a speed in a certain direction, like 60 miles per hour north. For our purposes, we will not distinguish between the two. For example, a car travels 115.5 miles in 1 hour and 45 minutes. Find the average speed of the car in miles per hour and in feet per second. First, we need to convert the time to hours. Since there are 60 minutes in 1 hour, the total time in hours is 1 plus 45 over 60, which is equal to 1.75 hours. To find the average speed in miles per hour, divide distance by time. Speed equals distance divided by time. Our distance is 115.5 miles. The time is 1.75 hours. And if we divide that, we get exactly 66 miles per hour. To convert to feet per second, use the fact that 60 miles per hour is equal to 88 feet per second. So we'll multiply by a unit ratio of 88 feet per second to 60 miles per hour so that the miles per hour can cancel. And if you do 66 times 88 divided by 60, you get 98.6 feet per second. Angular speed is the ratio of how much an object rotates to the time taken to rotate. The rotation can be measured in degrees, radians, or revolutions, or as you'll see in another example later, orbits. The time can be measured in any time unit of measurement, seconds, minutes, hours, days, etc. Specifically, if an object rotates an angle of theta over time t, then the angular speed of the object is given by omega equals theta over t. This is the lowercase Greek letter omega. It looks like a curvy W. So how much we spin divided by how long it took. For example, a tennis player swings a racket through a 90-degree angle in just 0.045 seconds. Find the angular speed of the racket in degrees per second, radians per second, and rotations per second. To calculate the angular speed in degrees per second, we simply divide. The angular velocity is 90 degrees divided by 0.045 seconds, which is exactly 2,000 degrees per second. To convert to radians per second, we multiply the previous answer by pi over 180 degrees, our standard conversion multiplier. So in radians per second, our angular speed is 2,000 degrees per second times pi over 180 degrees, which is about 34.91 radians per second. To get revolutions per minute, RPMs, Go back to 2000 degrees per second since that answer wasn't rounded, and let's convert to rotations per minute. To convert to rotations per minute, we first multiply by one rotation is 360 degrees. And then to convert from seconds to minutes, we multiply by 60 seconds over 1 minute. And that gives us an angular velocity of about 333 rotations per minute. What is the linear speed of the racket? We discuss that in the next video. Now you try. Pause the video and try the following. This is your fair warning if you haven't paused the video yet. Solutions in 3, 2, and 1. I do want to remind you that for the angular velocity, sorry, I'm thinking about the next video.